Good evening, good morning to all the people around the globe. So this is Sai. So uh, I'm a full stack developer who had been working with the software industry for almost close to 8 years. So starting from monolithic architecture, which was built around 7 to 8 years back with the legacy frameworks like J2EE, Java J2EE, and then span around with JSPs, and then with Spring framework with different entities like Hibernate stuffs kind of thing. And then from a mobile perspective, I have worked with native Android applications, and then slowly I worked for a short span of time. I worked with hybrid model of applications using PhoneGap kind of thing. And fortunately, in recent years, maybe a couple of years before, I started to work with cross-platform mobile applications using React Native framework from Facebook developers community kind of thing. So it's a brief outline about myself. Okay. So, as a developers, we know we generally collaborate with a lot of peer developers within the team as well around the globe. So it's not like whatever that expertise that I have gained out all these years is not about only about my effort or something like that. It is purely about the things that I learned from all my peer developers around the globe, starting from all my peers to the great legendary architects kind of thing. So this learning process, exploring new stuff is it's always inevitable quality of any developer, right? So as a part of that, recently I was going through some architectures in terms of microservice, and I came across something interesting architecture called hexagonal architecture. So before talking about this hexagonal architecture, so whenever we say there's something like really interesting or a new thing that can be adapted, right? We need to have a sole purpose for that, right? Any without a proper benefit or a sole benefit, attaining something a new thing into our existing system will not be that much fruitful, right? So to in order to achieve that one, in order to explain the benefit that we're gonna reap out of the hexagonal architecture, I would be explaining something about a traditional architecture which has been followed in a wide range of application development. Even to me, like most of the, not most of the, many of the applications, whatever that I have developed, I have used that architecture. So that architecture is nothing but called as layered architecture. The name itself implies that the architecture is going to be a different layers kind of thing. So when I say layers, uh, the number of layers, it's not going to be concrete. It depends on the different perspectives or parameters. The number of layers might differ from applications to application. uh, Predominantly, the layers could be like something like presentation layer, and then the business or the domain layer, and the service layer where the business is being implemented kind of thing, and then last one is the persistent layer. That's nothing but database layer kind of thing. Okay. So quite often, in most of the cases, the business layer and the service layer will be clubbed to a single layer kind of thing. In this architecture, uh, it is itself, the architecture itself says like each and every entity is lying at the one by one kind of thing, and the request and the transactions, everything would be channelizing the direction of vertical lines. A request comes from top to bottom, and the response goes from all the way from bottom to top, right? But this architecture, as a developer, is really smooth and cakewalk architecture in terms of implementation. It's really a cakewalk architecture, really an easy way to implement it. But as a developer, one of my recent assignments, I really found something like this architecture as a something has to be worked out in a better way kind of thing. Because in one of my recent application, what I came across is like we had an application where we were using for almost we are using Oracle database for almost for 5 to 6 years of timeline, and over the period of time, due to various reasons, we had to migrate the entire persistent layer from Oracle to Azure SQL layer. Okay, so conceptually, it is simple. You are just going to migrate the data layer kind of thing. But technically, it was not that much straightforward. It demanded itself an immense amount of effort, and we series of developers and SDETs played around it for a series of weeks on it. The major effort that we spent over there is, even though we had used some ORMs like Hibernate kind of thing in this architecture, which would little bit cascade the, I mean, little bit isolate the data layer from the business layer and give some kind of abstraction. Even in spite of that, we had immense amount of work to work on this business layer kind of thing. Just because we are migrating this data layer from this entity Oracle to SQL Server, Azure SQL Server kind of thing. This is not the only case. In other case also, each and every perspective, okay, there is a direct dependency mechanism is being implemented in this architecture. When you say UI, it has been directly dependent on the service layer. Obviously, any application, the delivery point is going to be dependent on the service layer only. But when it comes to service layer and the database layer, the dependency can be neglected to some extent. It need not. See, for example, when you say about business standpoint, business need not worry about whether I'm going to use an Oracle database or a SQL Server database or a no SQL database like Mongo or Postgres kind of thing. They don't have to worry about that one. A digital application is the one that is going to leverage this, should be like leveraging the existing business capability only, like that one only. It's not going to be like, it should not be like something a burden to them. To be more precise, I would say like an application, a digital application should be an entity that would leverage the existing business model. Okay, but rather in this level of architecture, right? In sometimes, or maybe in most of the times, what happens is like the program itself is more focusing on the upgradation of the framework or the application layer, rather much not focusing on the, not actually, it is not like not focusing on the business layer, but the upgradation layer and the business layer are being equally being balanced out. you know any application, whatever may be the technology, okay, the sole purpose of the application should be always built around the business only. Business is the major vital factor of any application. It is the heart of the application. If the business is not there, no matter how much ever high performance application we have, it's going to be the failure. So given that into the major constraint, building upon application in this architecture, what happens is like all the entities, like non-business entities, database, UI, REST controller, REST APIs kind of thing, whatever may be, they are all being built out in the same balance like as a business entity. And with this kind of same balancing mechanism, a lot of not physically visible or easily visible, but uh, what to say, like illusion based a tightly coupling mechanism is being implemented eventually. And this is being noticed only when this kind of migration related activities are being undergone kind of thing. In a straightforward way of application development, this kind of thing might not impact a lot, but given that today's market condition, whatever the technology entity that we're going to use it in our application is going to be outdated in a matter of weeks or a month. The entity that we might be using today might not be as advanced as for tomorrow or maybe next week. Because anywhere, today I'm speaking now, at this moment of time, in other part of the world, a new application would have been launched, a new library would have been delivered, a new entity would have been delivered. Who knows? No one knows that one, right? Because today the application digitalization is a rapid model, not like decades before. So in order to adapt, in order to make our application, our business to withstand the market condition, we are in a position to adapt the core latest technologies on the go forever. It's going to be forever kind of thing. It's not going to be static. It's going to be more and more dynamic. Given this kind of dynamic culture of entire digital world, having this kind of architecture is going to be a little bit more effort demanding application development process kind of thing. And now this entire dependency and complexity is going to be get ridden to the greater extent with our interesting architecture called hexagonal architecture. Apologies for my handwriting, guys. Like seriously, I'm bad at my handwriting styles. I'm to some extent I'm good at my typing style, but not at handwriting. Uh, sorry for that. But anyways, coming back to the point, the name hexagonal architecture, right? The name itself depicts like the architecture is going to be in the form of you know hexagon structure, hexagon shape. So this is going to be the base skeleton of this hexagonal architecture. The major fact that this architecture is going to be built out is like it is a domain centric architecture. When I say domain, the business, business is the major important factor that going to fall as a the nucleus point of the application. It's going to be, as business is the heart of the application. It is to going to be considered on a top priority, on a isolated, at the same time much more stable or stabilized way of development is going to happen with this architecture. Here, the core part of the entity of the system will be the application. Application is nothing but the business. Okay. So each time when I say business, 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 what is this business all about? A service that is going to, or maybe that is going to provide some capabilities to the consumers. Right? That's business. So when I say from a stakeholder perspective, business is going to be a set of capabilities that's going to be offered to their customers. For example, if you say consider an e-commerce application, okay, uh, registering a new user to the e-commerce application, allowing them to search through the wide range of products that they have, and then allowing them to place an order with their own favorites item and getting it shipped to them. This entire cycle, it is actually different capabilities, business capabilities of the an e-commerce application, right? From a product owner perspective, these functionalities, these capabilities can be called out as use cases, or maybe an agile model they call it as an epic, or some different terminologies, whatever maybe. All these things are verbal concepts or verbally actionized process, right? If you ask, for example, an e-commerce application is going to have an immense amount of user base, customer base. Okay, so there can be a range of capabilities that would play around the customer itself. For example, a customer can get himself or herself registered to the application, okay, as a new customer, and later point of time they can update their own details like updating mobile number or email id or a shipping address kind of thing, and they can place the orders, and they can just provide the customer feedbacks kind of thing. These are all different action items that would play upon the entity called customer or the user. So from a product owner perspective, use case would be like something like update user details, and the entity on which this use case will be acting upon will be the user entity or the user object. Okay, so when you say about business, an entity along with their respective use cases is going to be forming as a business, right? Every time when you say business or a domain, an entity along with the use case is going to be the business domain, right? That's just what going to be implemented in this capsule of hexagonal architecture. Okay, E, E stands for entity, and UC. UC stands for use cases. For example, E is going to be the user of the e-commerce application, and use case is going to be update user details. So from a business perspective, things has been covered over here, right? And okay, this is all about we have covered the business area. Now, how we are going to implement from an application perspective? As a developer, I've got the requirement from the business team to have an entity and then corresponding actions. But now, how am I going to implement that? That's what we're gonna discuss it now. Okay, so whenever we say about entity and use cases, when we are implementing that in a real time or programmatic way, right? We build it something called as services. That is going to be falling over here. Services are the ones that is going to define the use cases in a way how a use case will be implemented, how a use case will be acting upon the entities, business entities, kind of thing. That is where going to be defined under the services. Okay, so services is going to be the major facilitator for the implementing the business area from a technical perspective, from a developer perspective. So all these areas, right, no matter a service, right, whatever language I'm going to develop it, it is not going to have any direct dependency for what is the database I'm going to using, what is the um, consumer that I'm going to provide my service, kind of thing. It need not worry about it. I'm going to develop a service. For example, update user details. It is going to be a basic functionality that I'm going to implement it as a service. Okay, whether I don't want to worry about whether this update mechanism has to be reflected in a user web interface or a mobile interface, or whether I'm gonna do it in an Oracle database or my SQL Server database. I don't have to worry about it. I need to focus only on the use case implementation with the help of services. So this level of isolation will be achieved in this architecture. Okay, now let's see how our applications entities, when I say application entities, user interfaces, databases, message brokers, or all the technology stack entities, right? On a whole, when we are shipping an application to the customer or the business team, we have to deliver as an application itself, and the application is being built upon these entities, but they will be played on top of the business unit. Okay, so these entities, like whether it's a UI, mobile UI, or web UI, or database, or message broker, or a service bus, right? They all fall apart from the business layer or the domain capsule. Where they fall, that's what we're gonna say something like call it as infra layer. When I say infra, it is not only about the DevOps end, like servers or the what is whatever maybe physical entities, kind of thing. It is not about that alone. I call that infra itself as something like all the entities which are external for the business system, like UI, API, maybe the database or message broker, whatever maybe. They are all external. They can be of anything. Okay, whether I'm going to use Oracle or SQL Server or MongoDB, business need not worry about that one as far as reserving the database. I mean, data storage perspective, right? So those things are all going to fall under the infra layer. Okay, UI, API, DB, what to say, message broker, kind of thing. Everything going to fall under the infra layer. Uh, Before here, how these external entities are going to interact with the business layer. That is where going to be happening with two different uh, objects or two different persons who are going to get involved in this layer. They are called as adapters and ports. Let me show you how they are being classified over here or how they are being represented here. In between the infra layer and the business layer, there is one virtual or illusionic layer will be built out. That is here every external entities like UI, API, message broker, DB, everything they will have an interaction or communication with the business core business area with an interface called adapters. This is what called adapters. So this adapter is going to be forming like, for example, like a tunnel kind of thing. Okay, where these entities can directly connect with that, or not directly, but they can connect and communicate with the core business area. So how do they connect? Okay, they are not going to directly connect. Okay, as I said sometime before, they are not going to directly connect to the business layer, because if we are directly connecting the business layer, we are exposing the business layer to them in a way that we are creating a dependency with them. When you say something, exposing something to another one, when you expose one thing to another thing, eventually we are creating a dependency between the two things, right? That is not going to happen here. Here, the business layer will never get exposed to the external internet or the global world. Why I'm saying internet or global is UI, API, everything are global. End consumer is going to consume it, but they are not going to have a direct visibility to the core business area. And that level of abstraction, is going to happen with the help of something called as adapters and pods. I will give you an example, real-time example, how this is going to happen. Consider I'm a postman. Okay, I'm a postman or a courier guy. Okay, I'm going to some house, like something like house number might be like 555. I'm going to the entrance. The house is bigger. At the same time, they are more transparent. Like all the doors are open. Okay. What happens is like I'm going to entrance of the house, and I'm gonna call someone, maybe a security guard. Okay. I'm gonna say that so and so X person from this house has got a courier. Can you please hand out this courier to them and get a sign for me as an acknowledgement kind of thing? I'm gonna ask them, and the guard is going to get my uh, uh, courier from me. Okay, and he's going to travel inside the house, and consider that house is in the form of layered architecture. Okay, first the guard will enter the door, and then he will be directly going to the living room or hall, reception kind of thing. Then the actual intended person might be available in the dining room or some other room kind of thing, puja room kind of thing. So he will go all the way from here, reach the person, inform them that about the courier, get it signed, and then he will come all the way from here. So I will be standing here. In this level, there is a high chance, like, I have a complete visibility of the application. I'm in the house. Okay. Given that I'm a hacker, sorry, I'm not a hacker, but if I'm going to have a complete visibility of an application, right, or maybe complete visibility on a house, there are high chances that I can do any kind of. I'm not going to do it, but I'm just ridiculously saying I can plot a hacking plan on that house, right? Definitely, there's a high possibility for that. But as a house owner, I would ask, like, consider if the house owner is my friend, I would recommend my the house owner, who's the recipient of that query, right, would always make sure doors are closed here. But you know, keeping the doors always closed, exposing, when it comes to only doors, exposing cannot be 100% achievable. Okay. Either way, it can be visible to the outer world, right? So the entire house has been compromised over here. There's no privatization, right? Similarly, in application, when you build it in this architecture, when you say Spring application, a request from browser reaches to the web server, maybe to the from web server it reaches to the Spring container, and from there it reaches the REST controller. From REST controller, will have a direct connect to the service layer objects. Okay, service layer objects, and service layer object will direct have connect to the, have a direct connect to the persistent layer or maybe the database layer through ORM. This controller point have a complete visibility of database transaction. Complete visibility. Even though the controller is not to directly going to database, that is not going to directly connect to the database, but it has the visibility. Its entire system is public, right? That should not be happening out, for sure, in order to make the applications much more secure. Now, in this hexagonal architecture, consider the same example. Consider I'm going to a house where there is a two boundaries or compound walls are available. Okay, first, as an end user or the courier guy, I'll go to the first entrance. Okay, that will where the security guard will be deciding. I'll be saying that please hand over the courier to the concerned person and get the acknowledgement kind of thing. I'll be standing here. Okay, I'll hand over the parcel to the courier guy. The courier guy will all the way long walk around that path and reaches to another compound where there is another gateway. Another door is there. Okay, but that door is completely closed. Whenever there's a request, at that time around the door will be opened. Okay, at that door endpoint, there will be another person. Okay, who will be able to talk only to the security guard. Okay, security guard will say that there is a request to be hand over this request to the concerned person and get the acknowledgement. That is port, right? The person that acts as a port player, right? It is just an interface. That port doesn't know that where the person is available, okay, or what he or she is doing. No idea. He or she, the port person, right, doesn't have any idea on that part. If the port person itself has not going to have any idea on that part, how does a security guard would have that visibility? And if the security guard is not going to have that visibility, how does the end courier guy, I'm going to have that visibility? So when the security guard handles the request to the port actually calls the interface, a service interface, not the directly service. It's going to call an interface of that service. Service is the, when I say interface, it is the use case. Okay, but actual implementation will not be known. It is like inside the home that the port person might just call out the name of the person, but he or she might not know where the person is residing and how to reach that person. He might not know it. He will hand over in a, maybe consider there is a pipeline connected in the house where he can place the courier and turn on the button. The courier would go through the pipeline and finally it reaches the concerned person. So that pipeline will be called as like use case implementation called service, and the entity, the concerned person, would never be contacted by the either of the persons directly. So the request will be processed, and you consider in application perspective, this service layer again might have some dependency to have interaction with database also, maybe with message brokers also. These level of transaction details are completely hidden to this layer. There's no connectivity at all, right? Here there's connectivity, but here there's no connectivity at all. So the port itself would not know where the request is being channelized and how the request is being processed and how the request is being connected with the lower level entities, database or message brokers. He doesn't have any idea about that one. After a while of time, the service will be processed and the response will be only the response will be channelized to the port, and port will hand over that response to the adapter, and adapter will hand over the response to the end user. And probably adapter might have some kind of uh, very lightweight operations like serializing, stringifying, or maybe wrapping in a different format kind of thing. Those kind of minimal actions alone, the adapter might have facility to do it, and it can deliver the uh, outcome to the end consumer. So in this entire architecture of channel of transaction, you can clearly visible that entire business system and how the business system has been working is completely been abstract to the external internet world. That's a really a great benefit that we're gonna repeat of this architecture. And one more thing, here, from a testing perspective, there's a great advantage. Here, whenever when we talk about this part, right, testing as well from a development perspective. In this architecture perspective, most of the time we might need to be forced to have a concrete entity being developed. For example, from the beginning itself, I need to think about, okay, I'm gonna use uh, Oracle or a MySQL Server as a database entity for this application. At this beginning stage of itself, I need to figure that one as an architect or a developer kind of thing. But here, since because it has a direct dependency, but here I don't have that dependency. Business layer is going to interact only through the adapters. It does not worry about what is the database is going to happen, being lying upon the external gate, right? Data, it can be a database or maybe a data DB stubbing model or anything, maybe even a normal data source files. It may be of anything, but business layer they not worry about that one. So business layer development will be completely isolated from the external dependencies. So development can be accelerated in a much more aggressive, positive way. And in terms of testing, mostly testing perspective, especially in this agile model of testing, guys will be speaking around with something called test pyramid, where the lowermost layer of the test pyramid will be like, a lot of business related cases, unit test cases kind of thing. The huge variety of cases will be covered in that layer alone. So that level of testing approaches and strategies can be much more efficiently applied with this architecture, where I'm going to directly test the business layer irrespective of the external entities. I don't have to worry about it. So my coverage will be predominantly focusing on the business layer functionalities rather than getting channelized through the non-relevant entities. So that the quality of the application, the core part of the application, will be covered to the greater extent. And any time, that's really an awesome benefit. You know, without even having a direct impact on a single impact on business layer, I can play around with all these external entities in a plug and play model. Because business layer is not going to know about whether I'm going to use Oracle DB or SQL Server DB or a MongoDB. It is just going to interact with the adapters alone through ports. So if I want to change the database from Oracle to SQL Server, I don't have to touch the business layer or the service layer. Rather, I'll change only the adapter. Got it? And if it's going to be UI, initially I will be developing with web application. Later, I might be developing a mobile application. For mobile application, handling the request, or maybe the another some other protocols like an application with built out with gRPC protocol, something like that. Whatever may be the external entities that would require a delivery of service. Anytime I can plug into the system and work on it without having an impact on the service layer or the business layer. So business layer will be highly stable and the infra layer will be much highly dynamic in a way that would facilitate the business layer to adapt to the latest market trends as and when required in a much more easier way. So this is a greater advantage that we can attain or reap out of this hexagonal architecture. So this is the big picture that I've covered up here, yeah, about the hexagonal architecture kind of thing. And implementation wise, yeah, it is really awesome. It's pretty straight. Maybe probably like from seeing this architecture, things might be a little bit weird to implement it, how to implement this part of things, since I've used of some terminologies like adapters and ports kind of thing. But technically speaking, they are all different objects with different scopes. Okay, here all the objects most often will be in a public scope, but here this entire system is going to be in a private scope. That's really awesome, right? So testing also will be attained to the greater extent, and end product will be much more quality driven product. We can achieve a lot of immensive amount of quality can be covered with this approach of development. So this architecture as a whole, from a holistic picture, we can apply it to the application level itself. But for now, as a practical implementation, I'm doing this for each and every microservices, whatever the application that I'm working on it, right? So I'm developing microservices itself, by self-contained microservice itself in this architecture. So things are pretty much great. Really a lot of benefits that I can reap out of this. So yeah, apart from this, I have different things from a microservice architecture, different design patterns and things are being involved. But yeah, that's all, not relevant to this part. But anyways, I hope this was really interesting with examples, and really helpful for you guys to explore new stuff. Probably, when I say new, this architecture is not new. Definitely, it's not new. It's a, it's been available in the system for quite a long period of time. But uh, guys like me who might feel like this is a little bit interesting and new to get implemented in order to report greater benefits and accelerate the adaptation to the trends of market to the greater extent, kind of thing. That's a lot for your time. Once again, I wish you a great week ahead. Okay, so probably next time I'll come up with something interesting topic to discuss upon. All right, not always technical, but since I'm a technical guy, I'm a technical passionate guy. Obviously, I'll come with technical stuffs, but probably not always the core of technical. But probably I'll come up with some other different interesting stuff later point of time. Okay, thanks a lot. Have a great day. It's a Monday. It's a really awesome day for developers and all other people. So I wish you have a great Monday. Yeah, see you. Bye bye. Take care.